We're often asked, how do you do two processes at the same time? You want to do a couple things, and you want them to happen simultaneously. And strictly speaking, you can't do two things in parallel with a PLC. But if you structure your program well, you can make them, everything happens sequentially, but you can make them so that they happen so back to back that for all practical purposes, they are happening in parallel. And I want to show you a little bit of how to do that kind of thing. It often comes up, especially when you're dealing with subroutines. Somebody will ask, how do you make a subroutine run and my regular program run at the same time? Sometimes people get stuck thinking they can only operate their subroutine till it's finished and then go back to the main, or they want to do a couple subroutines at once and they'll think that they got to be stuck in one until it's done. That kind of scenario. But that's not the case at all. So we'll go through how to structure these properly. So in this case, I've got a simple program, and this will be available in the tutorial section of our website. We've got a main routine and then a subroutine here. I'll show you a little bit about the subroutine. In this case, I've got I'm going to be passing in a couple of the output bits, and we're going to do this by reference. So this subroutine will actually be able to change the values that are seen on the outputs. And the subroutine is going to be real simple. We're going to start a timer, and then we're going to compare it to some values. If it's been operating less than a second, it'll turn off a couple bits. If it's been if it's less than 2 seconds, it'll turn on the first bit, turn off the second. Less than 3, it'll turn off the first, on the second. Less than 4, it'll turn on both. And then if it becomes greater than 4, it'll actually reset a timer. And what's going on in the logic here isn't all that important. It's just that I'm trying to illustrate that you've got a process that takes an amount of time to happen, and just because it's happening and it goes through a 4-second cycle doesn't mean we need to be stuck in this subroutine for those 4 seconds. That wouldn't be very useful at all. So the way this subroutine is structured is you come into the subroutine, you do some comparisons. Based on the value of those comparisons, you do a couple actions. You turn something on or off, something of that nature, and then you've got it designed so that you immediately go to a return statement. And when you go back to the main program, all the data inside your subroutine will be retained. Your timer is going to keep going. Your values are going to be retained. You don't have to worry about those disappearing just because you exited the subroutine. So if you go the first scan, and it's in this case, and we come back and the clock is ticked such that it becomes in this case, that's fine. Nothing's been reset. So we look at our main routine here. It may become more clear what we're doing. The main routine is going to do something else very simple. We're going to take an input bit, and we're going to turn on a different output based either on or off based on its condition. And I've got a little simulator stick here. I'll switch this to debug so you can actually see what's going on. But the basic idea is I'll be turning on or off an output based on this input bit. And then the other important thing that we're doing here is I've got the whole program in one big loop, so that every time we're going to go through and we're going to do both of our operations, or you may have 6 or 12 you may have a whole lot of operations that you wanted to do, but you want to form it all in one loop so that everything that you want done every scan is done every time. So what we're doing in this case is, you see we're doing the comparison, then we turn something on or off, and then we loop to our subroutine. And when that's done, we start the whole loop over again. So this lets us do a couple, and since this one, it exits all the time, it's constantly free again to do this loop. So I'll go ahead and program this, and we'll see it in operation, and you'll kind of get an idea of what's going on. So I'm turning it into debug, and I'm going to look at the values here. So I'm going to flip this switch. I've got a little simulator stick. I can flip that. You can see it turn on and off, and you can see that it is, in fact, turning on and off my output. But at the same time I'm doing this, and I'm going to keep switching it back and forth just so you know this is still going on. You can also see that the subroutine is causing these bits to go in their sequence that was described. So these two tasks are basically happening in parallel. And this shows you don't have to be stuck in a subroutine. In fact, you don't ever want to be stuck in one. You want to be getting in, doing your operation, and then immediately getting out. And we can set a breakpoint here. You can actually see it go through its program. So you see in this case it was off, so it goes to the no statement on the is it on, and then it goes to the subroutine, and I'm doing a step in, so I'll go into the subroutine. And you'll see, in this case, it happens to be value 1929, which is less than 2 seconds. These are millisecond units. So it's going to fall to here, and then it'll take the yes path. And we exit it, and we immediately roll through again for the next comparison. And since I haven't switched it, it happens to be that no again. Okay, so again, the code will be available on the site. And hopefully this helps you to do multiple things at once.